Okay. Yeah, just let me confirm that we are broadcasting.
Let's hope people haven't come to the 30th floor.
Yes, this change I didn't expect, but you know, it's part of the game. Just 1 second. Hello. Okay. I think the game. Okay. So we are broadcasting. Very nice. So one more time, welcome. And today, I was thinking a long time, like what should be the first topic for this year. And since we don't have like many participants that wanted to present, I decided that I'll start, and hopefully this will be my last presentation for the year, and all other presentation will be somebody else. But for now, it's me. So why Service Fabric? I think it's a very interesting question because in my private conversation with a lot of Microsoft people, when I always ask them like, what are the technologies that we should pay like a close attention? What is the most exciting technology that you talk? And depending on their context and their profile, they'll tell me one technology that they're experts, and they always say, but always look into Service Fabric. This is something that we will constantly enhance. And it's there, it's very powerful, but in my opinion, still doesn't have a lot of attention to it. And maybe one of the reasons we were talking before the presentation is that maybe it's so powerful that it covers so many different different applications. So it's a little bit different to describe it, and a little bit difficult to compare it with other technologies. So today, I want to talk about Service Fabric internals. When I was preparing this talk, actually, there was so much material. So my initial intention was just to have like one presentation on Service Fabric, but after that I realized that it's impossible to fit everything in one. So today it will be again kind of like not introduction, but a little bit more rich content above introduction. But again, I see it more like a series of presentations where this will be the first one. So let me see. So I want to start with a very short video that was actually on channel 9 that explains what is Service Fabric. Let me see. Okay.
Traditional monolithic apps coupled all their functionality tightly to one service. This meant long downtimes to deploy new features, resulting in fewer opportunities to make updates. Scaling monolithic apps to meet demand was expensive and slow because every component scaled at the same rate, regardless of use. Likewise, availability and reliability were achieved by hardware redundancies, adding more cost and complexity. The cloud has changed the way we design and architect applications and deploy them as services. Time to market, availability, and ability to scale on demand are more critical than ever. This has resulted in a shift towards building microservice-based applications. This approach splits each application into a set of fine-grained, loosely coupled services that can be updated and scaled independently of each other, improving agility and efficiency. However, to make the microservice-based approach work, developers need to write additional code in areas like inter-service communication and handling failures. This is where Microsoft Azure Service Fabric comes in. Azure Service Fabric is an application platform that simplifies building and deploying microservice-based applications to provide organizations with scalable, agile, and reliable applications, whether they are run in Azure, on-premises, or in other clouds. And developers get to focus on code that delivers business value, which means customers get new features faster. Azure Service Fabric protects applications against failures by monitoring the cluster and automatically acting to mitigate issues. Azure Service Fabric provides built-in programming models to simplify developing microservices. Not only that, it lets you run any application code. In addition to supporting traditional stateless microservices, Azure Service Fabric supports stateful microservices, co-locating compute and data to reduce latency and enhance performance while providing reliability through replication and persistence. Data partitioning services, along with dynamic resource balancing, make scaling on demand routine. Rolling upgrades enable zero application downtime, and if health checks fail, Service Fabric automatically rolls back the application to the previous version. Azure Service Fabric was born from our years of experience delivering mission-critical cloud services, and today, hundreds of organizations are realizing the same benefits of a microservices approach. Not only that, but several key Microsoft products run on Azure Service Fabric. Service Fabric support for many developer tools and programming models improves developer productivity. These can be used to build stateless services the traditional way, or novel stateful microservices, where compute and data are co-located to further decrease app complexity. Azure Service Fabric also provides powerful management capabilities, including state management, application lifecycle management with zero downtime upgrades, easy service discovery, and detailed diagnostics and monitoring. In addition, with the support for Linux, developers can use the tools they know to build and deploy Service Fabric applications on Linux. Azure Service Fabric is designed to meet the needs of many industries, including manufacturing, financial service, gaming, IoT, or any application that benefits from added scalability and resiliency. Azure Service Fabric simplifies building and deploying microservice-based applications in Azure, on-premises, in other clouds, and is available on Windows and Linux as well. With Azure Service Fabric, organizations can deliver their customers more features faster to drive better business results. Get started today.
Okay, so as you can see, Service Fabric is so many things. It's a very, very powerful technology. And today I want to expand based on this video and go in certain areas and explain some of the key concepts. So first, let's start with the fact. When we develop for the cloud, we face completely different challenges. First, we don't own the hardware. We don't have control over it, and failures are something typical that we need to expect that will come in our development and management of resources. Also, sometimes scale is unpredictable. What does it mean? It means that sometimes if there is like a major outage, let's say in Japan East region, if people try to move to Japan West, it's not, you cannot be sure that there will be enough resources for you. So this should be planned, and you should design your system in a way that you can accommodate these changes. And this is very interesting, especially for me, because I'm coming from application development background. So here it says that managing services is actually more difficult than deploying, their development. And this is becoming especially true with frameworks and systems like Service Fabric that abstracts a lot of the complexity, especially with the new microservices concept. So Service Fabric is very powerful runtime for development of microservices, but also the real power is coming also with the advanced DevOps capabilities that provides. And of course, when we go to the cloud, it's already not acceptable to have a downtime for maintenance. And something that is very interesting, actually, we were working very closely with Mike on that, how you control your costs in the cloud. It's very easy to start. It's very easy to forget your virtual machines. It's very easy to spend money that actually can be saved. And this is directly connected with the concept of density. So how many instances of your service you can install on a certain amount of virtual machines. And of course, you have to be very, very careful. So the security is in place. So maybe a lot of you know about microservices. Maybe a lot of you are convinced why microservices are the right approach. And it's not just like some fashionable trend now, but basically microservices allow us to build faster, more reliable, and to be more flexible. And the major difference is that before that, when we're building like all type of systems, we were having this monolithic type of systems that were containing in one big, large blob, the whole system. And when we wanted to scale it, we needed to move it to different servers, but we didn't have the flexibility. So you can see on the other side of the slide, when we break the application in a small microservices, we have the chance actually to scale particular microservices depending on our needs. So we have a lot of more flexibility. But again, this comes at a certain price that we will talk about a little bit later. And this is the typical design that we see with traditional applications. We have API, we have UI, we have like a common libraries, we have like a data access. So as you can see, there are certain advantages and disadvantages. It's a lot easier to build a system like this. We all know how to build this system because we'll be building this system for a very, very long time. No, we have like a compile time contracts between the different components of the system. We have like a local operation. It's a lot easier to understand. On the other hand, when we move to microservices, the things become a little bit more complicated. Now, a single request to your system potentially can be served by multiple microservices inside the system. One request can be equal internally to 5, even 10 requests, depending on how busy is your topology. And again, it's getting kind of difficult, especially understanding this topology, optimizing the topology, how these services are connecting with each other. On the other hand, with the service-oriented, actually, this is the microservices type that I was talking before. Again, the disadvantage is that the networking is becoming a little bit more busier. You have like more moving parts. This is both flexibility and disadvantage because ideally, if something starts to fail, then only this particular microservice should be affected, not the whole solution. And again, there is a lot of advantages about like price optimization and so on. Something that is very interesting, and here we start to feel a little bit of the uniqueness of Service Fabric. Basically, Service Fabric most of the time is compared with other container orchestrators on the market, like a Kubernetes, Mesos, Swarm, and so on. But something that is very unique is the ability to create like a relatively easy, stateful services. So as you can see here, in the traditional approach, we are keeping the state in a centralized database that is accessed through the 3-layer typical application. On the other hand, on the other side, we have microservices, where each of the microservices is responsible for its own data store. And when we are talking about microservices, it's only possible to build effective microservices if we build them on a stable platform that will allow us to manage this ever-growing number of microservices and be able to very efficiently release, update version. So going from this more general concept to something more specific, Azure Service Fabric. So if you want to describe what is Azure Service Fabric or what are the key features, basically we are talking about like lifecycle management, independent scaling, independent updates, always on availability, resource efficiency, and stateless and stateful type of applications. So most of these things are common for the other orchestrators as well, but the development of stateful applications and also another very interesting capability that's not mentioned here. Service Fabric is very good at balancing the cluster. And it has a logic that is a very advanced logic that allows Service Fabric very quickly to find information about the cluster and be able to find the best resources, best locations for the resources. And another huge advantage, of course, that you also saw in the video is you can deploy Service Fabric in multiple places, not only in Azure, on-premise, on AWS. Microsoft people, and usually they talk about Service Fabric, they don't say AWS, they say other clouds. But you can see here, even the color here is yellow. So it's run on AWS. And we have people in the audience that can confirm that I think it's a good fit. And of course, something that is very powerful. You see here this laptop. Like, what does it mean? Of course, this is the local development, right? But what is interesting is, like, for example, if you have experience developing cloud services or developing for Azure storage in your local machine, you know that you're having an emulator that actually simulates the work that you will be doing in Azure. Something that is very unique for Service Fabric is actually the code that you'll be running on your local machine is exactly the same code, exactly the same runtime that will run in Azure. Just the cluster is smaller and the resource a little bit smaller, but it's not emulator. It's actually the same runtime that you're using. So again, you should be, you have a higher level of confidence that what you develop locally and it works should behave the same way in the cloud.
Excuse me.
Yes.
In that case, do we need to have our own Visual Studio to emulate Service Fabric application?
It depends. So if you're on a Windows machine, we will look that thing. It's a lot more convenient to have a Visual Studio because Visual Studio comes with templates. So then basically creating the whole structure for Service Fabric is very, very easy. But but actually it's not required. You can have the runtime only installed. You can skip the Visual Studio, but then you need to basically know how to place the files in certain order and be able to compile them, right?
From scratch.
Yes.
Okay.
So you don't get the advantage of the template that will create for you the files, and you just need to add your own small modifications on top of it. But it's not required. And it's very interesting. I haven't tried that, but there is in the end of previous year, there were like a private previews for the Linux version Service Fabric and also support for Docker containers. So as you can imagine, there is no like a Visual Studio for Linux. There is Visual Studio Code, but basically for Linux, any editor will be okay for you. Just again, you need to know how to structure the folders, the files, and be able to compile it. But you're not required to use Visual Studio. Just Visual Studio will give you, will make it easy for you.
Yeah, you need to build Azure Service Fabric-based application.
Yes. So what you need actually to do, you need to go and download the Azure SDK that contains the Service Fabric part. This will, and you will start on your machine the runtime, and then this runtime will create for you a cluster. And something interesting, like last year, the only option for this cluster will to have like a 5 nodes cluster, but from recently you're able to run like a 1 node cluster. So for example, if your laptop is not so powerful, it's 1 node cluster, yes. Because most of the cases, if you develop something small, I think like maybe 90% of the cases you are concentrated on the logic. You don't want to play so much like a kill 1 node, like a start another node. So 1 node cluster, it's good enough.
Thank you.
Sure. And here it starts to get a little bit interesting, right? So this is like a very high level how one Service Fabric cluster looks like. In front, we have some ports that are open for web requests, usually port 80 or 443. We have a load balancer. And after that, we have usually 5, or depending how many nodes you want, inside the cluster. So each of these nodes have the Service Fabric runtime inside. And then we have like our own code. So this code, basically, here it looks that it's all the same code, but actually this is not true because the Service Fabric decides like, where to put what service. Actually, when we develop for Service Fabric, we basically create services and they have applications. And when we deploy to the cluster, basically these entities are created, and the Service Fabric dynamically decides how to place them. And we'll see a little bit later when you decide to deactivate a node, they're dynamically moved. And there are certain advantages if you go after serverless or stateful or stateless that we'll look into. But basically, on very, very high level, what is the cluster? This is a set of virtual machines that have like the runtime installed, and after that we have the application code added. So something that is very interesting is when I first heard about Service Fabric, the people, even inside Microsoft, were calling it PaaS v2. Like before that, Azure started as a very heavy oriented platform as a service platform with cloud services, with websites, where basically everything was very high level abstraction. We didn't know the virtual machines that our applications are run. We didn't have access to this part at all. And now Service Fabric is a very interesting evolution of this concept. Of course, it's again platform as a service in the sense that there is like a binaries and logic and runtime that we don't have full control of it. But the difference now is that when we create like a Service Fabric, we basically specify the number of virtual machines we want this framework to run on. But we have access to these virtual machines, so we can connect to them. So it's like a cloud services, but different kind of taste. But the important thing is, again, you have access to these virtual machines, and we'll see why a little bit later. And again, please, if you have any questions, don't hesitate to stop. Right? So I talked a little bit already about cloud services. So cloud services was, in my opinion, one of the first platform as a services on Azure. A lot of people use them. I can tell you, like when we start using them, we are very confused. Like in what cases we need to use websites, in what case we need to use cloud services, when we need to use web roles, worker roles, and all that. And now slowly cloud services losing popularity because of Service Fabric, because of the serverless compute, because partially of app service, but still they're like very much in the core of the platform. Actually, Microsoft internally uses a lot of cloud services. You can see even this in the URLs of some of the services that you create, like cloudapp.net, cloud.com. All these URLs are coming from the cloud services, and behind the scenes, a lot of the services actually run on top of cloud services. So cloud services are here to stay. They will not disappear soon. But again, there is some issues with them, and here we list some of them. So for example, one certain problem is that you have like a one-to-one mapping between your application and virtual machine. So this was good like maybe 2-3 years ago when we didn't have so like a high demand for applications. But now you can see on the other side of the picture, you can have like a multiple application on the same virtual machine. You save costs and you use the resource of this virtual machine, which is very important. One of the biggest issues with cloud services that I had like for a very long time is that the deployment of cloud services are very slow. Usually it can take up even to 10 minutes because sometimes the virtual machines need to be created after the application deployed. Everything started. You can have like some events that are executed before the deployment. So it's very, very slow. And also the scaling is slow. And we, as we mentioned, we're using emulator for deployment. So again, it can work on my machine. When it goes to the cloud, maybe it won't be the same behavior because it's just this is limited emulated behavior. On the other hand, on the other side, the microservices, we have very efficient use of our resources. We have like a very fast scaling, and this new feature, one box cluster for development. So basically. You can run like a one node clusters, and it's very, very lightweight compared to what we have before that with the cloud services. So there is several ways how we can interact with the Service Fabric, and this is one of the confusion that I see a lot in people. Like most of the people think for Service Fabric as a framework only for microservices, but actually this is not true. You can use Service Fabric in many different ways. As a runtime, basically, you can take any application that you can package well enough, put it on Service Fabric, and just use the runtime capabilities, the management capabilities of this framework. Basically, it will allow you you define how many instances of these applications you want to run on Service Fabric, and the Service Fabric will take care of that. So if one of the nodes goes down, it will create another instance. So on the very minimum, you can think of it like just orchestrator of container. Unfortunately, it's not Docker container yet, but its own your own small container that wraps your application, right? So this is the guest executables. Basically, everything that you can package. And here, package. Imagine you have like a Java application. You need to have like the Java runtime. You need to have like your other dependency. You create this package together with your source code, and then you instruct the Service Fabric to get access to this package, put it on top of Service Fabric, and then the Service Fabric will orchestrate it for you and take care that it's running reliably on top of it. So this is the bare minimum. This is almost like a lift and shift. You have your application on your data center, your old application. You want to modernize it. You just move it to a new platform. Actually, nothing was modernized so much. But then, if you have a little bit more time, you can look into the unique SDK capabilities of Service Fabric. Basically, start to work with reliable actors or reliable services. So what are these ideas? So reliable actor is a very interesting concept that basically it's a framework that allows you to simulate objects. And each of these actors is independent object. Today we will not talk so much about it. We'll have like another session that will go a little bit deeper on this concept, but it's very easy to imagine. BMW, for example, has a good application. They use Service Fabric, and each of the drivers is basically one actor. And this actor has like a certain properties, and you can have the convenience of this actor communicating with each other. So we have like a one-to-one mapping between object from the outside world to the one object on top of the Service Fabric. On the other hand, you can create more typical applications that we have today, just like a lower abstraction with reliable services. Reliable services are basically using reliable collections or reliable APIs that allow you to perform operations on top of Service Fabric and be sure that they'll be performed in a reliable manner. So we'll talk a little bit later about stateful services, but on very high level, you can imagine that you have these reliable collections, like dictionaries, queues, that allow you to store data in reliable manner on Service Fabric. What does it mean? This means that you're storing data, you're defining a replication factor, and one of your nodes is down. This is not a problem because another node already has the data, and the data, the primary node will be shifted to one of the stable nodes. We'll see this thing a little bit later. And we go to the last column. This is for the people that have experience with the .NET, Web API, ASP.NET Core. It's very easy to run these frameworks on top of Service Fabric. This, from a code perspective, it's actually the same code. And has like a very good interaction with the framework. So again, guest executables, you take what you have now, package it with all the runtime independency, you put in Service Fabric, and you use Service Fabric just to orchestrate without taking advantage of a deeper integration with APIs. On the other hand, if you want to take the full advantages of Service Fabric, you need to use the APIs. And if you want to do something that is between, you want to use your favorite .NET framework, like a .NET Core or Web API, works perfectly fine on top of it. And this list will actually be extended because the team shared that, especially for the Linux distribution of Service Fabric, they support Java. For Windows, they don't support Java yet, or maybe they support, but it's in progress. Java will come to Windows. And I think this will enable a lot more developers. But the interesting part is that they want to extend the support for languages and runtimes a lot above the current one, C# and Java. And how they will do that? Basically, they'll implement the framework to a basic, I think machine code, something like that, that very basic level. And after that, on top of that, they'll add the support for different runtimes. Like let's say Java and C# already exist, so there are other languages that that community is interested in using, and then it will become like an even more universal platform for use. So this is already coming. They did that partially for the actor model. Actor model is supported on the Linux with this with this way of work. They basically re-implemented it in a lot more friendly manner, not so much dependent on the underlying frameworks. And now let's talk a little bit about the two different model of services that are supported on Service Fabric. Again, when we develop for Service Fabric, we develop services. The services has applications, but the services are the two main types: stateless and stateful. So stateless is the typical one, the one that we learn to develop when we are developing for cloud. So basically, everybody who asks you how you should develop for a cloud, everybody say, oh, it should be stateless because, you know, the virtual machine can go down and you can lose your application. You shouldn't keep state because it's so dangerous, and you end up in these like weird cases that you don't know what's going on, and it's very difficult to debug. That's why we learned that everything should be stateless, and we should use queues for communication. And we should have like a multiple virtual machines or like a services that take care of our compute. And we should have a storage that is stable and that keeps our store. So this allows us, for example, if our web layer is down, one of our web front end is down, we will continue to operate, right? Because let's say if our workflow is like we have a request that is coming from the front end, that will create like a message to the queue, and after that, the compute layer, independently from our front end, will take this message from the queue, and then based on the computation, will send some records to the storage, right? So if you have like a failure of each of these layers, queue will protect you, and then the next compute node that is ready to take the message will do it. And this is the typical way that we're building applications so far, and this worked well. We can scale. Basically, if we see that we have a lot more traffic on the front end, we just scale the front end. If we have like a very heavy computation, we just scale the compute layer. If we have a lot of messages in the queue, we're just adding new queues. So we thought that this is the best pattern, and we work with that for a long time. And still, this is a very, very valid pattern for a lot of use cases. But this is actually something very interesting, because this is bringing the difference between Service Fabric and the REST frameworks, like the stateful service pattern. So why it's so unique? Because actually allows, as you saw in the video, to have like a very close co-location of your code and part of the data that you use. So they're on the same virtual machine. You don't make network calls. It's super fast. It's basically it cannot be faster, right? Because your code is here, right next to it is the data. And now, why we didn't use this thing before? Because actually it's very difficult to manage it. Imagine that we store the data on the same virtual machine where our code is, and the virtual machine fails. Like, what are you going to do? Like, the difficult part is the replication. How do you replicate this data? How you keep it in reliable mode? And for that, like, Service Fabric is taking care and make it easy for us. So here you see what is the pattern. We have the load balancer, we have front end, which are basically stateless web. But after that, we have this interesting compute layer that actually shrinks the architecture, and potentially we can have only two-level architecture: web and compute and data combined in one. So in this architecture, you see that we have like an additional layer, which is for cold data store. So imagine that you keep most of your data on the second layer, but after that, for Hadoop and big data processing, you want to push the data in a colder store that you can have like a more like an archive, let's say for several years back in time. But again, this is one of the huge advantages of Service Fabric. And it's very interesting that because of this model, the team was sharing that financial institutions use this type of pattern to make like very complicated transactions. And again, for them, the speed of the transaction is very important. But what is even more important for these organizations is that we actually have a transaction that is reliable, and you don't have a chance to lose data, because then it becomes very difficult to to troubleshoot and understand what's going on. So for that, Service Fabric takes care, and this is very, very important. And from developer point of view, looks easy, but also there are some tricks, and we'll look into it a little bit later. Yes.
Excuse me, from my understanding,
Yeah.
I was a Java developer about 10 or 12 years ago.
Yes.
From my understanding, actually, it sounds like enterprise Java beans. Do you know?
No, explain me. I'm more on .NET side. Explain what is it.
It sounds right.
Very similar to this.
Mhm.
So
Yeah, so enterprise Java beans has also concept so related to stateless beans and stateful beans.
yes,
Mm. Yeah, because of that, so it's easy to understand too. It's easy to for me to understand the concept.
great. And with this Java concept, how did you make sure the data is reliable?
Mhm.
Do you have a lot of replication?
As for enterprise beans, so if we used stateful beans,
Yes.
developer don't need to care about how to store
Great.
data, how to persistent data.
Nice.
Mm.
Great. So exactly like this. Yeah, I didn't know about that. I would definitely try to find a comparison.
Mhm.
Yes. Yeah. I think that the idea is very powerful, and most of the ideas are not new. So this one example, right? But again, at least my experience with the stateful theory is that it's meant to be very easy from developer point of view. Okay, and this is like a high-level summary. Basically, with a stateless microservices, stateful is stored externally. We can have like multiple instances. This is usually our front ends, gateways, kind of cloud services. And a stateful microservices, we maintain hard and authoritative state. We have like a consistent copies. Even if the node is down, we don't lose our data. And this is more typical for databases, workflows, user profiles, shopping carts, some data that we cannot lose. So you remember from the video basically that SQL server is running on top of Service Fabric. I'm not sure like how deep SQL service is integrated with Service Fabric, but just you can imagine that now SQL Server have I think around 2 million databases in Azure. So Service Fabric proves to be like a very, very stable solution. And this is another interesting concept. What's going on when you want to update your application? So here we have different applications. One of the great powers of a Service Fabric is that allow you, like most of the orchestrators that we have currently in the market, to have like a slow rollouts. Basically, you update domain by update domain. As you can see here, the whole cluster is divided in update domains. So basically what we do, we first update the version of our application in the first update domain, after we go to the second, third, and so on. So why we do that? Because if we have a failure in the first update domain, we want to roll back. And Service Fabric take care of this. Basically, it checks the health of the application. That's why it's also very important to think and to have a good strategy what kind of information to push to Service Fabric. Because if it doesn't have enough information, it won't be able to help you. The default information is more about like a very basic health of your application, but it's possible that you inject information for your application if some of the module is not working fine. And Service Fabric will take this into account and say, okay, your application is misbehaving. I'm performing automatic rollback. Which is very, very important. I can tell you, like recently, I've been working a lot with DevOps engineers and site reliability engineers. Like having a strategy for rollback is a must. And most of the people, most of us don't think about this until it's too late, and then it's very troublesome to roll back. But basically, it's as simple as having a blue and green environments and switch back if something is wrong. But again, you need to plan for that. And in this case, actually you don't need to plan because the framework is built in a way that if something goes wrong, it will take care. Right?
Excuse me.
Yes.
Should we get that benefit even though we are running on that kind of application on premise?
Yes, because the runtime is the same, right? The runtime is basically of course there is advantage if you run it on Azure, but the core capabilities are the same. If you run it on AWS or on premise, you get this part. Yeah, I haven't tested, but I'm 90% sure that it should be supported. Yeah.
Interesting. Thank you.
Yes. Oh, okay. So let's make a very quick demo. Today, my demos are very basic because, as I explained, I see it more like a kind of a refresh of our previous talk that we have on Service Fabric. So here I have like a one virtual machine. And this is Visual Studio. And the only thing that I made here is just I installed the runtime for Service Fabric. Do I have it here? No, this is the Explorer. But basically what you need to do, if you want to start with the Service Fabric, you just write in Google or Bing, like how you need to set up your environment. And especially for Windows machine, it's super easy. There is like one runtime that you need to download. You need to have like a latest version of PowerShell and PowerShell commandlets for Azure, and you're good to go. And then again, back to your question, with Visual Studio, is that simple. Now let's create. Where's my mouse? So let's create like a Service Fabric. So this is one of the advantages. You come here, you have a template, you know, and this comes from the SDK. The SDK will install the runtime, and we will install also the templates for Visual Studio. So they're like a two distributions of this SDK. One is with Visual Studio tools, and one is just the runtime. So we come here and we just want to create application. And here, these are the different type of applications that are currently supported out of the box. We have like a stateless. Again, we don't have any state with that. We have a stateful. We have the actor service. We have the stateless web API, guest executable, guest container. This is preview. Yes, and ASP.NET Core preview. So my expectation is maybe by the end of this year, you'll be able to see here like a multiple lines. The team is really passionate. They want to onboard as much as possible developers with different backgrounds, different runtimes, because when they go to this like a lower level and add this like a wrappers on top of it that will accommodate like a multiple runtimes, it won't be difficult to scale for like a many different languages. So okay, let's start with this one, right? Stateless service. And again, the Power Visual Studio in the tooling, it will create the project for you. It will create the files, and this is it. Now you have your service. It's very basic. What you do, it's basically it will count. It will count and it will display some numbers. So let's see what will happen now, right? We press start, and what will happen? It will build, and it will deploy. Where is deploying? It's deploying to the local cluster. So what is actually happening, like for the first time, when you create your first Service Fabric application, it will tell you, oh, you don't have a cluster locally. I'll create a cluster for you. And this cluster will be the default cluster with the 5 nodes, but you can customize to leave only one, right? And see here, so it says that the application is ready. It's actually using behind the scenes a lot of PowerShell scripts that are pre-configured with the application, but you also can modify that. And here you can see we have this small icon, and this is actually our local cluster manager. So this is a very nice website written in Angular, and it shows like currently I have 5 nodes. I have one application. This is the application type. Basically, this is if you think like a object-oriented programming, these are our classes, and the application is basically instance of these classes. So this is kind of type. You can see that our application is deployed to node 2, right? So we have 5 nodes. Most of the nodes have nothing currently. Just like a node 2, we have something. This will be our application. So you can see here like how our application, everything looks okay, right? And let's see what this application is doing. If you go to the diagnosis, you see that it's just counting nothing and printing this to the diagnostic events window. So now we want to do the typical demo for Service Fabric. We want to kill this node, right? And to see is all this fuss about Service Fabric reality. So we want to restart the node. So a lot of things are happening in the cloud, right? So let's restart the node. We need to provide the name, node 2, and we want to deactivate or restart. So now let's start restarting and see what will happen. We don't want that. So now what happened? So of course our node restarted, right? So we're on a 125 index. We got an exception, and after that we continued. What does mean continued? This means that our application was moved to another node, but we lost the data, right? Because this is stateless. Yeah. So again, it very much depends on your configuration. Let's see where is now our application. Fortunately, it didn't refresh. Let's see fast. Yeah, it's on node 1. And as you can see, it was super fast, right? So we didn't need to do anything. So this is Service Fabric doing everything for us in this case. And now, of course, we can activate, because otherwise the cluster will start to complain. This red thing says that, oh, one of your nodes is down. This is not good. Maybe your cluster is under danger, right? So this is basically how easy it is to start with Service Fabric. You have the template. So now let's see the other option, right? What is the stateful? And we should see like a small difference. Again, this time we will not go very deep on the API level, but I just want that you get a very, very high level impression of the advantage between stateful and stateless. So stateful, again, super easy. Again, nothing different. It will generate for us the whole structure of the project. And we can run it. It will deploy to the cluster. And very soon we should see it on the cluster again. Okay, so it's creating the application. Again, everything is PowerShell here. There is nothing, there is no magic here. You can find the PowerShell yourself. You can modify if you have enough knowledge about the framework. Everything is very, very visible, very, very open. This is the kind of PowerShell that was executed. Let's see what's going on our cluster. So again, let's go on cluster level. We have again one application. This time it's our stateful application. It's application 4. It's on node 3. But now you see something interesting, right? We have primary and active secondary, 2 active secondaries. Why we need that? Because this is the data replication, right? So here, now we do the same exercise like before. And what will happen actually, we'll have a fallback. But let's see it, right? So just to show that everything is the same. Again, we are generating this count, nothing so interesting. But the interesting part is here. We come here. Our primary node is 3. So let's play a little bit with that. And say node 3, deactivate, restart. And what happened? The primary became 2. Active secondary became 3. And this one is lost. And now we are running in a new primary node 2 and active secondary 4. Let's see what's going on with our counters. So of course we have our exception, right? But we didn't lose state. From 65 we went to 66. So the state was kept. And how this was possible, right? It looks very interesting and a little bit mysterious. Let's go here. Again, we will not go very, very deep on that this time, but basically the magic comes from this stateful service inheritance. And after that, what you're doing, what is important here, you're using these reliable dictionaries that you're storing the data. And in the case of stateful service, you have this transaction. So basically everything in this scope here is a transaction. So this means if you have a failure here, everything will be rolled back automatically for you. But if you reach that line and you pass, this means that your data is replicated based on the replicator factor that you defined. So that's why. Yeah.
That's one stateful application, stateful module have 2 replicas.
Currently, it's 3 replicas. You have primary and 2 secondaries.
3.
Yes. Yeah. 3 replicas.
Basically.
Yes.
Could we configure?
Yeah, you can. Yeah, you can configure for very highly rare. But again, you have to understand it's like a trade-off, right? Because this is synchronous operation, right?
Okay.
No,
Performance.
yes. So it's a different thing when you like replicate in 3 places. It's different thing if you replicate 7 or 10 places. So it's a trade-off. Like, do you want speed or do you want reliability in this case, right?
Thank you.
Yeah, and again, this is super basic. Like, in the next presentations, we'll go a lot deeper in this model. But I just wanted to give you an impression how it looks. And again, all these reliable and secure transactions coming from the API. So again, if you use guest executables, you cannot take advantage of that. If you have like currently your Java applications on Windows, you cannot do that, right? It's just the .NET framework that you can do that you can use, and the advantage of this a little bit more advanced capabilities. Okay, let's go back here. So the next question is, you say, okay, I have my application, Service Fabric looks great. How I can migrate to Service Fabric, right? It looks nice, but how we do that? So there is no like recipe how you do it. You have to you have to analyze your application. You need to understand why do you need to move to Service Fabric, because actually Service Fabric is so many things, and you need to be very, very precise. Do you want to go over there because of the scalability, because of the agility, because of the resiliency? And to answer that, you need to take different strategies. So when we talk about migration, you have to understand that you have to make it as a phased approach. It's very difficult. We talk a little bit before the presentation. It's very difficult that you turn a monolith application to just a bunch of microservices. It takes a lot of thinking, a lot of trial and error in order to find the best solution. So one solution is just like a guest executable. You take the whole application and say, okay, this is my application, I want to run it in Service Fabric, but you don't change the code. It's the big monolith, the big thing that you have internally, right? The next option is you also start adding microservices on top of it, right? And then when you start feeling confident, when you learn how your application is behaving on Service Fabric, you start to break it. And then hopefully in one day you reach that level that everything is a microservice, everything is very granular, you can scale independently. But again, the cool part about this is that you can stop at any single stage and you can wait until you're ready to go to the next one. So you shouldn't aim to jump from 1 to 5. You can do it, but most probably you'll fail because it's very, very difficult. And actually, microservice, everybody talks how cool it is, but actually it's very difficult because you manage more applications, you manage more versions. It's a lot more managerial work. Again, the development is relatively easy. After that, managing and releasing and creating a stable communication between the microservices is kind of difficult. And let's see several patterns, how this thing is done. So how we usually interact with our service fabric, one of the most popular patterns is just you put a API gateway in front of it. And this gives you the freedom that, of course, you have the service fabric behind the gateway, but also behind the gateway, you have the flexibility of adding and removing components that is transparent for the users that are staying in front of the load balancer. So in Azure, you have several options doing that. Depending on the requirements of your application, you can put your own web gateway, or you can use API management, or if you have a very heavy traffic, you can use IoT Hub, which is actually event hubs behind the scenes, but you also have a device management on top of it. So again, you put these API gateways in front of your service fabric, you have the freedom to change a lot of things on the service fabric level without affecting the customers. And again, this is the same pattern. You're moving from client directly accessing your application, from client accessing your gateway, and then you're hiding the applications that stay behind the gateway. In this case, can be service fabric, but you can be also your original application. So again, when we're talking about this slide, you put the gateway in front of your application, and then slowly you take part in pieces and refactor, and nobody is affected. Your clients are not affected for these small changes that you make. The next big thing is how I prepare my cluster. So if you go to the Azure portal today, it's super easy. Like with 5 clicks, you have a cluster. But the problem is that this is not enough. It's very powerful, but you need to plan very carefully what you want to do. So this is like several questions that you need to address. The first one is one of the most serious. You don't want to run out of the capacity, because adding nodes, it's not trivial. Service Fabric is very powerful, but again, you need to know very well your application. You need to know like what is the expected traffic, and you also need to predict like how it will grow with the time. And the next point is also very important. You don't want to spend more money than what's required, right? Security is super important. Currently, you can run your clusters without certificates, without encryption, but this is not recommended. This is basically you're exposing your virtual machines potentially to attacks. So even though you have this option in the portal, it's very easy because you don't need to take care of certificates. It's not recommended. This is a big vulnerability. Something that is very interesting. Service Fabric, again, is this platform as a service, kind of service that allows you to touch the virtual machines. But also Service Fabric releases very often. And you need to be prepared for that because there can be some breaking changes. So currently how this thing works, you can control like will your virtual machines be updated with the latest version of Service Fabric, or this will be done automatically, or you can basically decide not to do it and you manually update when you're ready to do that. And the last question is like what will happen if there is a disaster and how my cluster will behave in that case. So in order to fix these problems, there are like 3 main buckets that are most important. This is basically cluster capacity, security, and management. So in terms of capacity, it requires a little bit thinking, as we mentioned. Don't think that it's easy to add nodes. It's not so easy. So it's better that you really study very well how your application will develop with the time. And also don't forget that most of the time you will be running several applications on this cluster. So you need to plan that thing and you need to be prepared. Like a Service Fabric is very powerful and the platform will evolve, but currently there is some like limitations how flexible it can be. And one of the limitations is around capacity. So capacity should be well defined in a short to mid-term time frame. Okay. So here, one of the most important questions that you need to answer when you're preparing cluster, what will be the role of this cluster? Of course, if it's cluster for testing, you're not so ambitious with your requirements. But if it's production use, obviously you cannot change it so often. Your customers cannot experience downtime. So it's not trivial if the cluster is production one. The next big question, again, where do you want to host this cluster? There is difference. On Azure, Microsoft takes responsibility for a lot of the things, for patching, for security. If you're on-premise or if you go to AWS, some of the features are not there, and you're the administrator. Again, disadvantage and disadvantage. Advantage because you have freedom, disadvantage because if you forget to do something, you have vulnerability, right? Again, about security, the best practice is that you have like at least two pairs of secure certificates that you rotate on a regular basis. And depending of your scenarios, you have to comply to PCI DSS or other certification. This also should be addressed. Here, in the one option is to use Azure Active Directory. So this is very, very easy on Azure. Active Directory may be on-premise. Again, requires a little bit more work. This, again, related to the capacity planning. We want to know like how many instances we need. We need to define like what is the replica set size. This thing that you are asking, right? If you're a financial institution and maybe if the speed of compute is not so important, but the reliability is more important for you, maybe you increase this from 3 to 10, right? But if you're like a social network that you want like very quickly to see how many likes people are putting under a particular photo, and you don't care like if you lose this data for a little bit, maybe the speed is a lot more important. Maybe you have like a replication set to minimum. And again, learn about your service, learn about the capabilities in core features, and then like tune the cluster in that way. Okay, here. The other things that you need to take into account, again, this is more like how the different nodes will need to look. And here we are introducing like two terms that I think most of you have experienced. This is like a fault domains and update domains. So basically, the fault domain determines like the headroom needed in case of unplanned failures happen. In update domains, these are the basically the resources that are required if part of the cluster is under update. So Service Fabric will be updated on a constantly to go to the highest version of Service Fabric. If you configure it that way, this means that part of the cluster at the moment won't be available, and you need to plan for that. So you need to leave a little bit space. So yes.
What does FD stand for?
Fault domain. Fault domain and update domain. So
okay.
Yes. So basically, this is the idea. Yes. So you divide your cluster in several fault domains, and you group, and Service Fabric knows that. So Service Fabric will distribute your services across fault domains. So you have to say, okay, here basically the top of the rack or like the power device will be down, and part of this cluster potentially can be down. Like a part of always. Like a part of every Azure data center is down for some reasons. Like some switch is down, or like some other device is down. So always there is something that is down, and you need to plan for that. This is something that you cannot escape of. So when you create the cluster, you define these fault domains. Service Fabric knows about that. It will distribute your application. It will leave a space, basically allowing you, if like one fault domain is down, to redistribute quickly the applications to cover that. But again, this means that when you're creating the fault domains, you should leave space, right? Because imagine that you don't have space, Service Fabric cannot move these applications, and this is it, right? Your application is down, your users are upset. So here the recommendation is you have to have at least space for one fault domain down, right? This is the rule of thumb in this case. So here, oh yeah, there is animation here. So here, you basically, this full domain is down. The power device is down. So this node doesn't exist anymore. Service Fabric detects that thing and start to distribute across the full domains, right? And you need to have the space. So that's why the capacity planning is very important. Same thing with update domains. In this case, we don't have any failure unexpected. We have like a expected update. So part of this cluster will be down for routine update events. So let's see what will happen. Again, you need the space, but basically it's happening the same thing. We are redistributing the resources. So now best practice. Our clusters have enough spaces to survive like one full domain down, one update domain down, in random nodes or VM failing additionally. So now it's getting a little bit easier. We even can come up with a formula for that. So one update domain down, one full domain down, and several virtual machines down as well. So this means that we need to provision a lot of resources and to have like a free space for that. Something that is very interesting, and especially for the people that have more experience with Azure, this is the best practice. Like clicking with the UI in the portal is fun, it's quick, but again, if you need to make it more than 2 times, it's better to have ARM template. ARM template is basically the code that provision your infrastructure. Is very, very important. It allows you to have a traceability. It allows you to have a versioning. It's very, very powerful. It's difficult. It requires knowledge. You need to learn it. It's JSON. It's not very straightforward. But what you can do in the beginning, you can create your a cluster in Azure. You can configure it in a way that you want to, and after that you can ask the portal to give you the template, and after that you can modify it and experiment for that. So this is a easy way to start. And if you work a little bit with that, you get slowly proficient, and then it will be easier to create your templates from scratch. But especially for production workloads, always use ARM templates. Don't just use the UI because you very easily lose control of what's going on. Something that is very interesting, especially when you have like a big deployment, it's recommended that you have different nodes. So when you create like a service fabric, unfortunately today I didn't go through the portal, but you're allowed to create a different type of nodes. And this different type of nodes can be actually based on different type of virtual machines. So imagine that you have, again, highly compute-intensive application. You go with the high-spec virtual machines, let's say 4 cores, 8 cores, like 20 gigabytes, 40, 50 gigabytes. Or you have something that is very basic, like a kind of like a batch operation, and you don't care, it will be 5 hours or 10 hours to compute. Then you can go with one of the lowest low-spec machines. So again, this gives you the flexibility, and when you define your service, you can define, please target this type of node, and Service Fabric will know to install only on these nodes, right? So here, what we see, we have like a certain service with 7 nodes, 10 nodes, 20 nodes, and we instruct Service Fabric where to deploy our services. And we know that we can expect a certain performance based on that. Cluster security, we touch a little bit upon that. But basically, the same rules that we know from our data centers, nothing new, right? We need to isolate the different layers. We need to limit the access. So basically, this is it. Like you define like your DMZs with the help like network security groups. Behind the scenes, Service Fabric is running on VM scale sets. These are virtual machines that can very easily scale up and down. But the important thing here is that you also define these zones that are isolated between each other, and you can define like who can talk to what. You have the load balancer, so they're kind of separated. So imagine that you have like your like a stateful services that you can treat as a kind of database. So then you can define like who can access them. Obviously, you'll not open that thing to the internet. Maybe only your API gateway if you want to access it directly, or if you have even web front ends on the Service Fabric cluster, only the front ends will be allowed to access the stateful services. But again, very, very similar things to what we do with the virtual machine in Azure today. And again, in terms of the security, there is no other choice. You need to use Key Vault for storing your certificates. Not using certificates is a recipe for big troubles. Also, you can use Azure Active Directory to control the access and to tie that thing to the user permissions. We have a lot of tools in Azure for diagnostics. Yeah, here a little bit animation. The other thing is Jumpbox, right? Again, this is common sense, but it's a best practices recommendation. You can only go to this cluster only when you go through the Jumpbox, and you limit a lot of the access that can go to there. These are the standard ports that are required by Service Fabric. And yeah, we talk a little bit about the cluster version. So as we said, like Service Fabric is constantly improving the version. But again, you need to decide, are you okay that Microsoft increased the version for you automatically? Because sometimes there can be breaking changes. And if this thing goes to production, you didn't change the code, your clients will experience like the failures, and it won't be pleasant. So there are like a very fine defined rules. You have like a 60 days to adopt a new version. A warning is generated every 14 days prior your cluster update. But again, if you switch to manual, this won't affect you. The disadvantage of that is that if you're on a manual mode and if you don't update, you continue to operate with the old version Service Fabric. If there's some issues, security bugs and so on, you're not running on the latest and the greatest. So again, you need to basically define how to do that. Here, the best practice is that you definitely run your production cluster on manual, and your test cluster is good to be on automatic, even the staging one. So you catch very early these errors and fix them before you go to production. Again, common sense, nothing new, but again, the flexibility is here. You just need to organize your operations in a certain way. Again, this is how you need to decide what kind of upgrade mode you need, depending on the cluster. Oh, this is very interesting. Debugging production. So debugging production is very exciting. Not so pleasant, right? It's usually when it happens, it's under big stress. So for Service Fabric, the recommendation is never do it, right? Because especially in microservices world, it's very, very difficult. You get error from certain place, but you're not sure that actually the problem is on this level because everything is so distributed. Maybe your request is forwarded to 5 or 10 different dependencies. How you guarantee? How do you find the service that is blowing these exceptions? Because there is this like a storm of error logs, and it's very, very, very difficult. So one practice, of course, is this is more like a generic for the microservices. You should have like a single identifiable ID of your request that travels around the chain of microservices, so you can track like where the request started and where it ends, so you can match potential exceptions, right? But the main thing that we need to remember for Service Fabric is we need to instrument our code. Like we need a lot of logs, we need a lot of information. We need this information to be aggregated and easily searchable. Again, common sense, but here this is becoming even more important because you have very distributed environment. Data loss is very, very interesting. So now we talked a little bit about like the power of Service Fabric supporting like stateful services. Yes, this is great, but at some point something will happen, and we can potentially have like a data loss, right? We have the replication factors. Like Service Fabric promise that everything will be fine, but there are small periods of time that even for several minutes we can lose the data. So we need to define that, like how tolerant is our business of losing data? Can we lose like a data for 1 minute, or this is too much? Is it 5 minutes? Most of the business owners said, oh, we cannot lose data. It's impossible. 1 second is too much. But actually, if you start asking questions, this is not true. You just need to dig deeper and understand like what is the really minimum maximum amount of time that you can allow yourself losing data, and based on that you need to build your cluster. Soft deletes is something very important. I'm not sure you're using it today in your systems, but basically the idea is that you don't delete data, you just mark it as deleted, but it stays over there. And then you have like a batch operation, background operation, let's say after a week or month, when you're cleaning these entries. And this is very powerful, because imagine that the client deletes their like a browsing history, and they say, please recover this information for me. If it's a hard delete, you're lost. There is nothing over there. So soft delete is something very important to have. Data corruption, again, very important to think in advance, like how much your business will be affected of that. And we have just a few minutes left, but I'll go very quickly on that thing, availability and reliability. So it's also very important to decide what is the optimal architecture for your solution. Service Fabric provides this functionality and promise that your application won't be down, right? But Service Fabric is part of a larger context, which is a data center region and so on. So if everything is okay in the data center, Service Fabric will make sure that you're up and running. But if the whole data center is down, what's going on? So then what we're doing, we need to decide what is our strategy. There are several options. The first one, you have like active passive deployments. This means that you're running two Service Fabric clusters in two data centers. And basically, you have a traffic manager that your clients are hitting. And most of the time, the traffic is served by the active cluster, or cluster A, until there is some issue. And of course, behind the scenes, we are replicating the data from cluster A to cluster B. So this is good. The only problem with that is that most of the time we don't know like what is the situation with cluster B, and when we need to switch, sometimes maybe we can be surprised. For example, some of the nodes are not in the way that we expect, or the data is not completely replicated, let's say. And again, this RPO, like how much data we can lose in this case, because of course this data replication requires some time. Will be 1 minute, will be 5 minutes. Again, depends very much on your own requirements. And of course, what is bad in this case, that you're running a whole cluster that you don't use most of the time. And this is some lost resources, but gives you the reliability in long term when we have issues with the primary one. The other one is active-active model. In the active-active model, actually, we have the two clusters that are working all the time. And of course, they're not fully fledged clusters. Basically, you divide the resources between the two, and you constantly replicate the data. Here, the complexity is that it's a little bit more difficult to develop because you have this constant replication of the data, and you can end up with a little bit race conditions. So it's not very straightforward, right? And here with the active-active, the main advantage is that you have like a fast and free failover, but you can end up in these awkward cases that you have like a dual reads, and again, a little bit lost capacity, because obviously you need to over provision, especially if one of the clusters go down, and it should be able to serve the traffic alone. So one novel solution for that is actually to have storage accounts. And like the storage accounts, they have like a read-only replication with another data center. So basically, each of the clusters is writing to and reading to two storage accounts. So you guarantee a little bit more flexibility. And again, storage is very interesting. Service is super fundamental, but when it's down, like most of the things in Azure are down. So this is a good practice, always to have like more than one storage account. Usually not what is happening. It's very rare. The whole storage service for data center will be down. Most probably like a certain cluster of storage machines will be down. And in this case, Microsoft is not performing failover. So you just need to wait until the situation is fixed. So never, storage is super powerful, but always think like what will happen if my storage resources are down, because you can end up like waiting up to a few hours to several days. And this can be disastrous for your business. So it's always recommended to use multiple storage accounts to reduce the risk of having a storage service down in particular area. Can you pick up this phone and just close it? They just inform us that our time is over. Yeah, I just close it. And I'll cover 2 more slides and we'll finish for today. Cascading failures. This is very, very interesting. So sometimes we have failures, but because our system is done in a way that we are constantly repeating and trying to recover, imagine that part of your system is down and the other parts of the system, the other microservices are programmed in a way that they retry. They assume that your service is down, but they say, okay, you'll be up after 5 milliseconds or 5 seconds. So let me retry until then. The problem is that when this problematic microservice again recovers, you have like a burst of the traffic and immediately goes down because you actually you did it yourself. You created like your own DDoS attack, right? So that's why it's very important to use the circuit breaker pattern that allows you to have like a exponential backoff. So basically, with the time, you increase the interval for retry. So you give a time for the service to recover, assuming that if it takes longer, probably there's a serious problem in it won't be so fast. And this is the reality. Most of the time, we cause the problems. It's humans, it's not technology. So automation is super, super important. We touch a little bit upon that with the ARM templates, but here the golden rule is if you have time to describe a procedure in a document, maybe you spend comparable time writing the automation script for that. And if you have the automation script, the chances that somebody will make something wrong are a lot less. So again, you see like a 60 to 80% of the problems are caused by humans. So computers are a lot more reliable than us. And something that is very, very important about the certificates, always be careful with that. I also have a lot of stories with these certificates, but even Azure had a big outage because somebody forgot to update the certificate 2013. So, you know, be careful. So let's stop for today. Here, there is a lot of material. This is just like a scratching the surface. This is again like a refresh on Service Fabric. I plan to have like several more talks on that, maybe not immediately, but through the year. Service Fabric will grow a lot this year. Again, from official and unofficial sources. Information is one, like please put close attention to this service. Microsoft is investing a lot. This is a complete differentiator service compared to the other cloud providers. And because it was run internally in Microsoft for 10 years, it can be easily compared to Kubernetes that is now developed by Google. So you can see how Kubernetes is growing in the Docker and Linux world. So expect Service Fabric to match this growth and even to provide a richer feature set. So thank you very much for your attention today. I hope it was useful and interesting. And I really want to invite you to test Service Fabric. You saw how easy it to start. It's not painful. You just need Visual Studio. But if you don't want, it can work without Visual Studio. You need to be a little bit more careful. And it's really a pleasure working with it and experimenting. And it's very easy from building a prototype to creating a little bit more robust demo to going to hundreds of instances of your application in Azure. So again, thank you very much, and hope you have a fun time with Service Fabric. Thank you.
so much.
Thank you.